This is lesson 4.9, comparing and ordering rational numbers. In chapter 2, use the number line to compare integers. You can use the number line to compare positive and negative fractions also. The number line shows that negative 1/8 is less than 3/8. And the reason for that is negative 3/8 is to the right on the number line. The number to the right is always greater than the number to the left. Graph each pair of numbers on a number line, then determine which number is less. So we'll do that. Negative 7/8 would be right about here. Negative 3/8, 1, 2, 3, right about here. So to the right on the number line is negative 3/8, which makes negative 3/8 greater than negative 7/8. Example number 2. Negative 5/8, 1, 2, 3, 4, 5 right here. Negative 1 1/8 is right here. So negative 5/8 is to the right on the number line, making it the greater number. So negative 5/8 is greater than negative 1 1/8. Number 3, negative 13/8 is actually negative 1 5/8. 1, 2, 3, 4, 5. We have to change that to a mixed number. Negative 3/8, again, negative 1, 2, 3 right here. Again, negative 3/8 is to the right on the number line from negative 13/8, so it is greater than negative 13/8. Number 4. Negative 1 7/8 would be right about here. Negative 1 5/8 is here. So on the number line, negative 1 5/8 is right of negative 1 7/8, making it greater than. Now in the next two, we're going to have to change our halves and fourths to eighths. So negative 1/2 would be actually negative 4/8, 1, 2, 3, 4. And negative 3/4 would have to be negative 6/8, which would be right here. So negative 1/2 is greater than negative 3/4. Then our last two, 1 1/4 would be 1 2/8 right here. Negative 1 1/4 would be negative 1 2/8, which would be right here. Clearly negative 1 1/4 to the right of the number line, to the right on the number line, greater than negative 1 1/4. The different types of numbers you have been using are all examples of rational numbers. A rational number is a number that can be expressed as a fraction. Fractions, terminating decimals, repeating decimals, percents, and integers are all rational numbers. The points corresponding to rational numbers begin to fill in the number line. Comparing rational numbers, example 1. It says replace the circle with less than, greater than, or equal to make negative 1 5/6 compared to negative 1 1/6 a true sentence. Well, you can see on the number line, here's negative 1 5/6. Here's negative 1 1/6. Again, to the right on the number line is negative 1 1/6, which makes it greater than negative 1 5/6. Check your progress. Replace the circle again with less than, greater than, or equal to make negative 5 5/9 and negative 1 1/9 to make that a true sentence by replacing the circle with one of the three symbols. So we'll just make something simple here. We'll make negative 5 here. We'll make negative 6 down here. Doesn't need to really be any more elaborate than that. Negative 5 1/9 is going to be very close to negative 5. Negative 5 5/9 is going to be a little more than half. So it's going to be over here. So the statement negative 5 5/9 to be true has to be less than negative 5 1/9, again, because negative 5 1/9 is to the right on the number line. A common denominator is a common multiple of the denominators of two or more fractions. The least common denominator, or LCD, is the LCM of denominators. You can use the LCD to compare fractions. Here we're comparing 7/12 and 8/18. The prime factorization of 12 is 2 squared times 3. The prime factorization of 18 is 2 times 3 squared. So the LCM is 2 squared times 3 squared, which is 36. We then use multiplication to write equivalent fractions. We multiply both the numerator and denominator here by 3 and here by 2. We get 21 over 36 compared to 16 over 36. So 7/12 then is greater than 8/18. So, in check your progress, 5/6 and 7/9. Our least common denominator is going to be 6 is 2 times 3, and 9 is 3 squared. So our least common denominator is 2 times 3 squared, which is 18. So 5/6 becomes 15/18, and 7/9 becomes 14/18. So 5/6 is greater than 7/9. This is example B. In example C, we're going to simply change 1/5 to 50ths, because 50 is our least common denominator, so this becomes 10/50ths. When we compare that to 7/50ths, 10/50ths greater than 7/50ths, so 1/5 is greater than 7/50ths. D, 16, as we know from our practice, is 2 to the 4th. And 10 is 2 times 5, so it's 2 to the 4th times 5, which is 80. So negative 9/16 becomes negative 45/80. Negative 7/10 becomes 56/80. So negative 9/16 is less than negative 7/10. You can see the value of being able to do prime factorizations to find least common multiple. In Mr. Hong's math class, 6 of 32 students own roller skates. In Mrs. Trevino's math class, 5 of 29 students own roller skates. In which class do a greater fractions of students own roller skates? Since the denominators are large, write 632 and 529 as decimals. So we're knowing that this is a numerical expression. Both of these are. We take 6 and divide it by 32. We get 0.1875, which is actually 1/8, I believe. 5 divided by 29 is 0.174, approximately. They've rounded it off here. So 0.1875 is greater than 0.1724, so 6/32 is greater than 5/29. In the check your progress, 12 out of 32. Students in second period class like to bowl. In fifth period, 12 out of 29 like to bowl. In which class do a greater fraction of the students like to bowl? Well, this is really a bad question, because 12 over 32 would be less than 12 over 29, because 29ths are larger than 32nds. So I wouldn't do any more work on it than that. The answer, of course, would be this class right here. You could change them to decimals if you want, but I'd save that for a better example than this one. This table shows fraction, decimal, percent equivalents that are used frequently. You should know these. Most of them you can make easy conversions, but to be where you're supposed to be, you should know fourths, halves, thirds, 3/4, and 1. These right here are all money, if you want to think of it that way. These are your fifths, these are your eighths that you should know. Easy to convert. These as well. Halves and thirds are 2 of your repeating decimals, and tenths, of course, are very simple. So, looks hard, not that hard. Pi is the ratio of circumference to diameter. These are the first few digits. They've done pi to thousands and thousands of digits. This is an irrational number because it never terminates. We're going to use it in our comparisons down here. We're going to use 3.1415 because that's about all we need. So what we're going to do is we're going to take 3.1415 and use that for pi. We're going to take 3.14. We're going to take 3.44. And 3 with a bar over it means 3, 4, 4, 4, and so on. So if we want to go least to greatest, it's going to be 3.14 is the smallest. Then 3.1415, which is pi. And our third number is this one. This is confusing because 3.44 is actually less than this, because if you wanted to extend this, they would all be zeros instead of fours. So this is our third, this is our fourth. So the correct answer would be 3.14, then pi, then 3.44, then 3.4 repeating, which would be D. So compare digits using place value. That's exactly what we did. We lined them up according to place value. We went until we came to a digit that was different in each number. We compared those digits. We came up with the answer of D. Down here, we've got another issue because we've got some decimals and some fractions. Now, if you go back to our table up at the top of the page, we know that 3/5 is actually 0.6. And we know that 2/3 is actually 0.6 repeating. So if we do as they suggest, we write 0.3, we write 0.6, we write 0.75, and we write 0.666 ... And then try and put those in order. The smallest would obviously be this one, 0.3. The next smallest would be 2/5, which is this one right here. So 1, 2. The third is 0.666, and again, that's similar to our example above, because if we extended these, they would all be zeros. This is our 2/3, and then 0.75 would be the fourth one. So we're looking for 0.3 as the first, 2/3, 2/5, then 2/3. Excuse me, it's 3/5. My mistake. So 0.3, 3/5, 2/3, and 7/5. So this would be our correct answer here, G. Check your understanding. 4/9, -4/9 compared to -7/9. Again, on the number line, -4/9 would be right here. -7/9 would be right here. If we're doing 0 to 1. So -4/9 is greater than -7/9 because it's to the right on the number line. Number 2, -1 3/4 and -1 6/8. Now they're messing with us here a little bit because what they don't hope we see is that 6/8 simplifies to 3/4. So this is actually -1 3/4. So these two are equal. We don't have to do anything to that really, other than recognize that it's not in simplest form. Number 3. And we got 3/8. And we got 6/15. Let's see, 8 is 2 to the third, 15 is 3 times 5. So what do we got? We got to multiply them all together, don't we? So we got 16 times 5 is 80. We got 240. So 3/8 becomes 2/40. 90 over 240, and 6/15 becomes 16 is 96 over 240, so 6/15 is greater than 3/8. Number 4. Two and 4/5 and 2 and 7/8. Now these are a couple that I should know decimal equivalents for. 2 and 4/5 would be 2.8, and 2 and 7/8 would be 2.875. So negative, or 2 and 7/8 is greater than 2 and 4/5. Table shows the average saves for 2 soccer goalies. Who has the better average? Well, 3 out of 4 is Elliott, which is 75%. 7 out of 11, I would take this and I would divide this by 11, and I would get, my first number would be a 6. And I could stop right there, and I could say that Elliott has the best average. On our first quiz, Marjorie scored 23 out of 25. This is number 6, which we would change to a percent, which would be 92%, because percent means out of 100. On her second one, she got 27 out of 30. What we would have to do there is simplify that first. We can divide that by 9, and so we get, or let's see, we divide it by 3, and we get 9/10, which is 90%. So her first quiz, 23 out of 25, was her best quiz. Lengths of 4 insects. Last problem. 0.02. 1/8 is 0.125 from your table on the other page. 1/10 of an inch would be 0.1. And 2/3 would be one of our repeating decimals, 0.6 repeating. So if we put those in order, and they want what? Least to greatest. So our least number would be 0.02, because it has a 0 in this place, in the tenths place. Then it would be 0.1. Then it would be 0.125, which is actually our 1/8. And then 0.6 repeating, which is actually our 2/3. So we're looking for 0.02, 0.1, 1/8, and 2/3. And so our answer is C. These are the vocabulary you should know for this lesson. Rational number is a number that can be expressed as a fraction. A common denominator is a common multiple of the denominators of 2 or more factors. And the least common denominator is the least common multiple of the denominators of 2 or more factors.